Question 8a. Three forces are acting on an object of mass 3 kilograms. And we have the three forces there written in IJK notation. The acceleration of the object is parallel to the vector I plus j. Okay, so part A, find the value of the constant c and hence show the acceleration is 6I plus 6j. It looks complicated. It's not too bad. When you have three separate forces done in vector notation, you can just add your vectors together. So add the i's, add the j's, add the k's. So we've got I plus 8cj plus 11ck, so that's a 1i there. We've got minus 14i minus cj minus 12k, and we've got 15c plus 1i plus 2cj minus 5ck. So I'm just literally going to add them together algebraically. For my i's, I've got a 1 minus a 14 plus a 15c plus 1. If you just tidy that up, you'll get 15c minus 12. So that's the amount of I you have. For the j's, you've got 8c minus c plus 2c. Okay, algebraically, that just gives you 9c. And for the k's, you've got 11c, take away 12, take away 5c. So join the 11c and the minus 5c and get plus 6c, take away 12k. Right, so there's two ways you can find the constant c. Either way will work. You could either say that the I bit equals the j bit, because in the acceleration it's going to be something I plus the same something j. Okay, if it's parallel, it's going in this direction, which is I plus j, but it could be 2i 2j or 3i 3j or 4i 4j. So as long as the I bit equals the j bit, that would work. So you could write down that 15c plus 12 is equal to 9c. Solve that, and that will give you c is 2. Or you could say that the k bit equals 0, because there is no k part to our acceleration. Now I know we're talking about force here, sorry, and that's acceleration, but remember you've got F equals ma, and mass isn't going to do anything apart from just give you a numerical factor. Okay, sorry, I didn't mention that. This is the total force, that is talking about acceleration, but the mass is not going to make a difference. So we can still think about what the k component of the force being 0 would correspond to the k bit of the acceleration being 0. Okay, so if the k bit is 0, we can write down that 6c minus 12 equals 0, and look, it's the same formula, the same equation we had there. So either way, we should be able to work out that c is 2. That means our overall force, we can sub in c is 2. 15 times 2 minus 12 is 18i. 9 times 2 is 18j, and then obviously that gives you 0k. All right, so your force is just 18i plus 18j. When you use F equals ma, and you've got 18i plus 18j as your force, and you've got m is 3, you will then just divide by 3 and end up with 6i plus 6j for your acceleration.